Okay, you filming?
Okay,
we're good.
Yeah. Well, so we could do acceleration.
To find mu, we took a board and we put the brick on the board and we rotated the board to find the angle at which the brick started to go down the board. So this angle would be the angle at which the forces going this way overcame the frictional forces that were going this way. So, if we draw a free body diagram for the brick, we have the frictional force that we're trying to find. We have the normal force from the plank onto the brick, and we have gravity. So, in order to find the frictional force, we can draw a new axis with these x and y's because the normal force, by definition, is perpendicular to the frictional force, and we get the normal force is on the y-axis, the frictional force is on the x-axis, and the gravitational force is on both axes. So we can separate this into two, where since this is theta, we know that this is also theta. So we can draw this triangle better. This is G. This is theta. This is G times cosine theta. This is G sine theta. And if we go back here, we know that this component right here, which is G sine theta, is the only force on the x-axis other than friction. So that means that friction has to equal G times sine theta because it was at equilibrium at this time. We also know, since normal force and this force, which is G cosine theta, are the only ones on the y-axis, that the normal force has to equal G cosine theta. We can now plug this all into the friction equation, which is friction equals nu times the normal force. So G sine theta equals nu times G cosine theta. These G's cancel out, and we get nu equals sine theta over cosine theta, or just nu equals tangent theta. And now we can use the theta that we got, which was 23 degrees. So find a blank space here. Nu equals tangent 23, which equals 0.42. The angle that we got, which was 23 degrees, has two significant figures, and so did our answer. And this means that we were probably off by as much as 0.01 in terms of mu, because that was our last significant figure. In the future, things that we could do to correct this would be to use a more accurate protractor to measure our angle, or to use a more homogeneous piece of wood, as our piece of wood may have had different coefficients of friction at different points.